Okay, so the idea behind my project is that your company knows more than I wrote down. So it's the idea that there's more information in their artifacts than we're giving them credit for. So the whole idea is that this is a new type of memory for agents, agent harnesses. It's observability for agents and organizations. So basically what I did was I took an open data set called OrgForge, and what that does is it simulates 60 days of a medium-sized enterprise called Apex Athletics. There's different events that happen, such as people leaving the company and database overloads. And while the simulation is running, it generates all these different artifacts, such as Slack threads, emails, conference pages, etc. So normally, in like a regular search that like an agent might be attached to inside of an organization, it might just find, when it searches, it might search Titan database and then just find this Slack thread. Whereas the whole idea behind this is that we're taking the metadata associated with these artifacts and turning those into edges and nodes on a graph that we can traverse using the Jack language. And so this does a lot of interesting things where like search can't regularly show you. So for example, was a post-mortem ever created for a database outage? Who carries this feature now that Jordan has left the company? Which domains are one vector away from being unowned? You can look at like the togetherness or the connectedness in the graph. So this is just showing how we took different artifacts, took the metadata, extracted it, and this is the little cartoon of what the graph looks like. This is the actual schema we use for the graph, for the artifacts. And then, of course, we're using the Jack language, like hardcore, 100%. So we use the Walker primitive to traverse the graph and like do all of the different kind of functions. So it's not purely LLM, you're not bringing 10 tokens, it's very efficient. So in terms of the benchmarks, so Vector Rag scores about 55.6% on the Hugging Face silence questions, and ours scores 96.3%. So we're doing a heck of a lot better. So into the app, you can see this is the default view. There's actually 22,000 different nodes and 70,000 edges. But we're only running with 3,000 because I'm on my little crappy MacBook Neo. So you can see each node in the graph, something different. So a person or a domain or an event or an artifact. So for example, this is Reese. Reese is a DevOps engineer and has authored 51 different artifacts. And an artifact might be something like this Confluence page. And then that's always connected to this kind of like domain link, for example, OAuth to Flow. So that's all well and fine. That's cool, but what can we actually do with this? So, for example, let's say that there's when was the last database outage and what actions were taken and how long did it take? So, that's a kind of interesting question that someone in management might want to know. So you can see here, so the memory that's or the agent that's running in this chat panel has access to a bunch of different tools to traverse the graph. So it's not just like burning tokens doing this. This is like kind of deterministic and not burning tokens. So you can see it's doing all of this. And we're waiting for it to come back. Okay, looks like it looked at 48 different. It got nodes, it got schemes, describe nodes. Once it's done, it's going to, here we go. It's rendering the kind of graph traversal that it did to get the answer. And then we can see the last database outage was a P1 incident. And it happened on day 21 and it was resolved on day 24. And there was a postmortem created. So that's pretty cool. But then the cool thing that you can do from here is you can ask, okay, well, who led that effort? I think I want to give that person a raise. Who was most connected to that? So we can ask that again. This is just showing that this chat window has memory. So this would plug in really nice with the command line interface for like an agent harness such as Cloud Code or Codex or whatever we use. So you can see, again, it's just running the graph traversal with the lockers, and then it's going to give us a kind of like answer. So yeah, we're seeing how it traversed the graph, and then it looks like Jack's the database edge response. So that's the person I'm going to do this to. So that's that's my project.